Good morning, everyone. Welcome to this Mirantis webinar on migrating from VMware to OpenStack. The meat of the matter are the two real-world use cases that we'll be going through that are examples of how to apply the planning sessions, etc., that we'll be using to migrate from the VMware platform to the OpenStack platform.
Considering a cloud transformation or migration? Check out the Total Guide to Private Cloud from Mirantis to learn how open source cloud on-prem gives you cloud benefits without the downsides. Download now at mirantis.com/privatecloud.
My name is Bruce Basil Matthews. I was a senior solutions architect with Mirantis for about 7 years. I'm actually retired now and doing an acting thing as my career. So what are we going to talk about today? We're going to take a look at the hypervisors out there in the real world. And we're going to do this sort of as a menu from a restaurant. We're going to do the starters, which are the appetizers, and just to whet your appetite about the session. And then we're going to move on to the finishers, the main course. And we're going to talk about a migration methodology from step to step. And really, the pièce de résistance is the real customer experiences at the end. From an industry standard point of view, VMware's vSphere and the SXI are in fact the leader in the industry for hypervisors. And they're followed by, you would expect, Microsoft Hyper-V, and then there are a few other flavors like Zen Server, etc. And finally, at the bottom level, number 4 in that usage, is KVM or QEMU, which is the hypervisor used by the OpenStack framework to do its virtualization. You'd think that with this much of a difference in utilization that, KVM wouldn't have a chance of catching on. But it's quite a good hypervisor standing on its own, and it has many of the features built into it that ESXi and some of the others have. So let's take a look a little bit at how VMware structures its infrastructure for you. And as you can see, there are the physical servers at the bottom with some kind of enterprise storage and enterprise network. They're really not concerned with that because they ride on top of the operating system that you have. So the underlying is going to be something like Red Hat Linux or Ubuntu or one of those flavors, and ESX servers then ride on top of that with their virtualization of the networks and the file systems, etc., to create your virtual machines. And you get to manage that in the top layer with some kind of vCenter, vSphere management software. And it has its console and high availability and all of those things. Each one of those layers that I am describing to you now are separately licensed products from VMware, now owned by Broadcom. So you can get an idea of the level of cost from this kind of diagram. So a lot of people, based on the fact that there are a lot of different products coming from VMware and some concerns about this Broadcom takeover of them and how things are going to change, have some concerns that may be driving them to look for alternatives. And we've got this chart in to sort of lay out some of the reasons why people change. For one thing, people like standardization on APIs that they can count on, both in the public and the private sphere. Another concern that people have is that once you get locked in to a specific vendor's technology, it's very difficult to get out and change. And hopefully what we're doing with this talk today is to sort of lay out a methodology that will help you get from point A to point B, even though you may currently be locked in to somebody like VMware. And the next thing is to accelerate your organization's ability to make innovation in how they do things. most companies rely on the infrastructure and infrastructure as a service to provide sufficient support for them to actually produce their product. And in order to do that, they have to be able to find new and better ways of doing things, bettering their pipelines, etc., to make all of that occur. And that's something that is now driving them to look for alternatives to something that's very rigid, like the VMware environment, and moving to something that's more flexible and that allows them more options to try new things. And the next thing is, of course, you want to make sure that your people are geared up to be able to operate efficiently, that they have the capabilities to perform the duties that they need to perform with the resources that they need to have at their fingertips to do them, so it becomes frictionless. And of course, saving money is a big one for folks, that they want their costs to go down, not up, on an annual basis. And looking at budgets and things like that coming today, you can see where that has a pretty significant impact. One of the other important drivers for change is to make sure that the talent you have available to you is at top notch, so that when you're trying to innovate, you've got people who think out of the box and can put it back into the box so you can actually use it. And of course, all the way through everything that you're doing, especially now with compliance and all of those things, you need to worry about security and privacy, and you make sure you're controlling the platform properly. So those are the things that are now driving people to try and move away from a VMware kind of environment to something more flexible and capable like that. Okay, now I throw this slide in sort of to give you an idea. It's pretty old. The numbers on it are rather old, so please don't quote me about those. But it was just to give you an idea of when you go about doing proprietary software licensing, that it generally comes down to individual licenses per feature or capability. In this case, like NSX is the networking stuff from VMware, and it's going to cost you, 3 to 6K to license it per cluster or per component. vSAN is their storage mechanism. It's going to cost you another 2K or so. vCloud is the management stuff sitting on top of it that you need for virtualization, visualization, logging, monitoring, and alerting, all of those things. And if you decided to go vSphere without vCloud and the suite that's associated to it, it'd still cost you about 60% of the cost you're paying for the vCloud stuff. And then the VIO is all of the new things that they're doing for it at the bottom. And they're going to license that on, $200 or at least 50 sockets at $200. Now, the thing about this is, and it's going to happen with Broadcom even more, they're going to standardize on how they do their pricing model. And it's going to be based on sockets, how many actual cores you've got within your chip. So if you're talking about Intel, there's like 4 to 8 processors or 2 to 8 processors within a single chip, and you have to multiply it by the number of cores. If you're doing AMD, you're talking 2448 cores, and their pricing is of that. So just multiply it out by that 2448. Now that could get to be really, really expensive, but the whole point is usually they break things down to about half the price of list for you to get it on the market. What does that mean in shifting from an VMware-based, individually licensed price software to an OpenStack, open source, all-in-one software that you get that does the entire job? Your capital expenditures are going to go down. And we've estimated that's about 40% over the 4-year period that you generally want to license things. The 4 years is sort of the lifespan of the technology, and that really involves those software licenses that I talked about, the type of commodity servers that you use. And in the VMware world, you're going to want to limit the number of virtual machines you can create and things, because that costs you more. In the OpenStack side of things, you'll be able to better utilize the hardware, physical hardware, by splitting it up into more virtual machines, because they all cost the same, whether you take them from this pool or that pool, from the OpenStack side. And your operational expenses are going to go down. Part of that is just the support and maintenance of it that you get from people like Mirantis. But your own people actually can add to that by gaining expertise and training and things like that at a much lower cost than the VMware certifications, et cetera, that you have to go through to actually run their costs. The commodity servers and things, sparing them out becomes lower. Your data center cost to run the OpenStack environment uses less therms and stuff like that than the VMware world. You can ask other people to do that. And as I indicated before, utilization is something that's really kind of important about that. We've actually made some lovely changes in our Mirantis OpenStack world from where we started. Basically started with the standard stuff coming off of the OpenStack Foundation, deployed by a tool we called Fuel, and it was, sort of written specifically to do the deployment and management of an OpenStack cluster. Now, everything was lovely about that, except when it came to updates and upgrades, where you would end up having to kind of shut things down to allow that to be updated and upgraded properly. In this case, we've come up with a containerized version of the OpenStack framework. So it's a Kubernetes platform hosting individual containers that provide all of the services. Mirantis Container Cloud Management is the deployment mechanism and has the lifecycle management stuff built into it. We take advantage of software-defined storage, Ceph, which is the community edition, so you're not paying additional licenses for that. We have our flavor of Kubernetes, which allows for Kubernetes to swarm. In this case, the OpenStack is sitting in a Kubernetes cluster. We manage the runtimes for the containers, so we've got the full stack sitting there, and we offer some additional capabilities to provide an on-prem version of the containers. So if you're air-gapped, for example, you'd only have to load things into your local image repository, and it would be able to do all of the LCM functions against it versus directly from the internet. And finally, we have this lovely thing called Stacklight. It's been around since we started, from the first versions of OpenStack that we developed. And it does all of the beautiful logging, monitoring, and alerting, because we've already managed to insert all of the probes throughout all of this system to take a look at everything. You still have a choice of operating systems. It can sit on top of Ubuntu or Red Hat flavors, or Fedora, or Rocky Linux, which I think is an interesting new choice that's coming to be. And your physical infrastructure, like I said, is bare metal, and it can sit in the public or private menu. You've been convinced a little bit that, gee, maybe we should start being able to look at a migration of this. And I stick this slide in not because it's informative about the process that we're going to be dealing with, but just to give you an idea, a flavor of how things start out very simply with this inventory, discovering all of your applications and everything else that you're going to be able to migrate. And then you start deciding whether you're going to do a rehost of things onto new hardware, lift and shift, as they call it, or re-architecting, rewriting the software to become more cloud native, microservice oriented, and all of those things. And in the middle, things get very complicated and timelines get overlapping and dependencies are become more vital. But all of a sudden, after you've finished all of that middle part and making all of those decisions, validating, transitioning to the new hardware, and into production should be fairly straightforward. So we're going to concentrate on that middle part because that's the most complex thing that you can be doing. And we're going to try and make it a little bit simpler. We're going to take that process and we're going to break it down into 6 steps. Yes, you're going to do your analysis phase and you're still going to go through the inventory, etc. You're going to need to talk a lot with your technologists and organizationally because things are going to change. You're going to start taking people from your development environment and bringing them much closer to your operations environment and vice versa, so that you can start developing this group they call DevOps to make things run very smoothly. At some point, after you've done all of the planning and everything else, you decide on launching a proof of concept. And in that proof of concept, you may take, say, 10 things, 10 items out of your inventory list that you got from the beginning. 1 very complex, 9 that are representative of the rest of your application services. And we'll talk about how you separate out the application services in a later slide. And then you want to take a chance and launch one of them at least to see how they do in the new OpenStack environment. Now, during the post-migration, the biggest thing is testing and ensuring that everything is going to go along smoothly, that you're going to get the same levels of performance, and that you haven't lost any feature or function during the course of it. And finally, after you've gotten through all of those things, you're going to have a continuing level of education for everybody, the dev people, the operations people, and probably your management layer to understand what the new OpenStack environment can bring to the table in terms of innovation. Let's go through each one of those steps a little more deeply. In the analysis phase, you're literally taking all of your workloads and you're analyzing which ones of them have dependencies like VMware dependent applications and services. And you're going to try and plan it out so that you've either alleviated those by rewriting the software or that you have other alternative software available to you that takes the place of it. You got to make sure that you have sufficient resources allocated. And that means building your cloud to a profile that fits the structure of all of your application services running in a centralized hosting environment. And you're going to make sure, doggone sure, that your training and skill level is up to the task. And that really means learning how to manage and operate this new OpenStack environment and having people from the development team who actually know, because it's software-oriented delivery of infrastructure as a service, how to assist in doing that effort, because operations people are generally hardware-oriented. This gets the whole team to be more hardware and software-oriented. In the next step, the technical decision-making process, you're dealing with the constraints of the organization, what we can and can't achieve with the number of people we have, the number of hours we intend to work to accomplish things, number of resources available at any given point in time, trying to fill any of those gaps by including people, training courses. Mirantis, by the way, has a lovely set of training and certification that goes along with the OpenStack environment that you can take advantage of to do that. You want to see where vendor lock-in has occurred with the VMware environment or any other environment you're taking things off of and moving to the OpenStack world, so that you don't hit a dependency that will prevent you from moving that thing. If you try to just forklift it and you've not removed the dependencies, you're going to find problems. And this is where you want to do it during the technical decision phase. And then setting up, as I said, these new avenues of communication between your operations team, your IT group, and your developers, your software writers. Those are the people who are going to make the money off of the hardware you're providing. Proof of concept. This can get really, really complicated. I only decided to put a couple of things on it. Don't eat the elephant all at the same time. Start with the tail. It's the smallest thing about the elephant. And then move on to the trunk, the legs. And as you go, you can build yourself a new elephant with devouring it one piece at a time. If you try and attack the whole thing at once, things are going to get disruptive, and you don't want to do that. And testing and validation is really, really critical. And it means that the operations team and the development team work absolutely together to test every aspect of what you're doing. Software folks are more inclined to do, break testing and things. Physical hardware people want to know how fast it speeds and feeds. So you got to get those two groups together to do this successfully. Okay, we said we talked about how you do an inventory. And this is sort of a way of profiling that I thought comes pretty close to helping you decide how to move things and whether you can do lift and shift or whether you have to re-architect. How many of the things in your world are traditional stateful applications that have dependencies, and those fall into the Oracle PeopleSoft, SAP, whether they're doing VDI or CRM or things like that. Those are big, heavy applications that usually have a lot of state stuff in them, and that need to be able to scale up to manage the demand against them. And then you have a whole other group that hopefully you've started moving your folks to, that we like to call agile, that have these cloudy, stateless kinds of web-based application service layers. Those things like Hadoop and things that were written for web-based cloud environments that you can probably just lift and shift. You've been successful doing a POC, it worked, and you're satisfied, and you're going to migrate at least one of those lift and shift, 9 of those lift and shift types of things, and one of those big, heavy, stateful things, and seeing everything works, and now you're going to end up migrating the entire stack. And once again, the validation and testing that you did in the first part are really critical to continuing all the way through. And that's going to happen in step 6 as well. You're never going to stop doing it. It's a continuous flow process. And in the post-migration, you're not only ensuring that there's enough hardware and performance and feature to do the things you need to go do in an ongoing operation. You're testing to make sure that your business can survive if something really bad happens to the data center, all of those things. You're checking to make sure that the OpenStack environment is as absolutely resilient as you had and built for yourself in the VMware. And I cannot emphasize enough, I am a perpetual student. I'm sure all of you are who are listening to this. Continue to learn. Keep your operations and development team current on the new platform. OpenStack releases their major releases every 6 months or so. Mirantis' version of that is slightly offset, but it's around every 6 months. You should get a new version, learn what's in the new version and features, and plan ahead, like become a part of that planning process in your organization to say, hey, look, guys, this thing is coming down the road. It's a new innovation that they've built in Masakari. We're going to have HA that's running in your world, and all of those kinds of things. You're going to be able to introduce those to your community. And quite frankly, the thing that I think is most important about the open source world, as opposed to the VMware world, you don't have to go back to VMware and say, hey, can you help me by making this new feature? Can you do this for me? And they look at you askance and say, yes, it'll cost you $1 million. You don't have to do that. You can actually participate in this world. You can create that new feature that you think everybody will love. And there's a whole community that surrounds it in the open source foundation, etc., that will help you to accomplish that. And you feel a lot better when you contribute to things yourself. We've gotten through all of the appetizers. We've eaten our meal of planning and all of those things. And now we're finally getting to, as I said, the pièce de résistance of this, which is to give you some idea of what happened during the planning. Now you'll notice I've called these two customers we're going to be dealing with customer X and customer Y. These are real customers. They're customers I worked with. The names have been changed to protect the innocent, and so that we avoid any kind of legal conflicts in terms of telling you stuff. But both of these customers started off with the idea that they wanted to get off of VMware. That was where we started on our first discussion. Customer X is a digital signing software business somewhere up where I'm now living in Washington, near Seattle. You probably know who they are. But they were off on this journey to get off of VMware and head towards OpenStack. Now, these are the things that actually drove them. This was not our assumptions about them. This was their talking to us in our initial planning phases for this deployment. And they're putting in place this whole project team that involved operations people and development people. And they were dead set on the practice of finding a leading technology that was going to be able to fill any of the gaps in their current environment and to fulfill new requirements they were coming up with. And they had had tremendous amounts of cost in both VMware licensing, and they were trying initially to do all of this stuff in cloud, and their bills were pretty high in that range. And so they decided to start with a reference architecture from Mirantis, and then they would set it up with the first target was to move everything that was on VMware off. So now they'd have a private cloud with their stuff, and they'd have the Amazon services stuff in their public cloud, and then they'd eventually reduce that by moving things into their private environment. And for us, it was pretty easy. Their primary purpose for doing it, use case for doing it, was to provide infrastructure as a service. This is the premier thing that Mirantis OpenStack provides, is infrastructure as a service tailored to fit your needs. And then, of course, they had to do the software-oriented architecture stuff and model over SaaS to make everything work the way it had been working in the prior environment. They wanted to be able to have a menu and hit a set of application catalogs and be able to deploy them. This was tailor-made towards a Kubernetes-oriented microservices world, and that was kind of where we pointed them, sitting on top of OpenStack. And I'll show you how that happens in the long run. And they were just like us at the time. They did CI/CD pipelining using derail and other tools, Jenkins. And lo and behold, our mechanisms at the time fit into those categories. So we walked in the door and we had done all of our homework over the planning phases of this. And we had our architectural design service meetings, and our solution engineering services got together after that. And we put together what we thought was, here, this is going to be the most perfect thing. And you can see it lays out over period 1 to period 12. So all of the epics were planned in individual cycles to meet their needs. And it was overlapping with the idea of the POC deployment going on while we were doing our architectural workshop. And we thought we had just covered every possibility, the production cloud readiness assessment, and how we were going to fit in the software-defined networking that they wanted using Contrail at the time. And our upgrade workshops to get us from our prior version of the OpenStack framework to our new version, MOSC, Mirantis OpenStack on Kubernetes. And then we continue to plan the upgrade going up into the final epic in week 12. And of course, all of that was happening while the engineering was going on below it to align with those things. And we thought we had done a great job. This is actually what we ended up with after the first couple of days of working with the customer directly. And as you can see, there's a whole lot more to it. But we had to accomplish the same things, the actual epics that we were about to achieve in the same 12-bucketed time frame, hitting all of these notes as we went. And that's the important part, that you may start off with one concept about this, and then as you go, you're going to flower it out. It's going to burgeon and become a beautiful bouquet of things you need to accomplish. Don't get scared. This is going to happen to everybody, and you're going to be able to take advantage of all of the planning you do to be able to keep up with it, so that the one thing that we put at the beginning becomes 4 things or 5 things, and the 3 things that we had at the end become 10 things. You can accomplish it. It's possible. Document like we're doing. Keep in the flow. Keep the steps going forward in those 6-phase steps, and you'll be able to get to the end of this. And we were successful. And customer X, still a customer, still running on Mirantis OpenStack, Kubernetes now. Life is good. Customer Y provides security at the edge. So they're a very high-tech oriented company. And they had already figured out what kind of services they wanted to do to things. And they were telling us what automation they wanted to be able to achieve using the OpenStack environment instead of the VMware environment, because their thing was to improve the speed at which they could provide the setup for their security at the edge. They were taking several months to provision one customer. And the first time that we had gotten the original OpenStack environment in place with all of the various things that we had gone through to accomplish that, it went from those several months to 5 days using automation tools they had developed to work within the OpenStack framework using the standard OpenStack APIs. It was a thing of beauty. In any case, this customer leads the world in this category, and they still do. They've got 68 regions out there, and we're scaling into each one of them. They have 24 data centers, and they've deployed this now at many, many sites over a 12-month period, and they're still doing so. And one of the biggest gains that they got from doing this was that they improved the storage performance they had been getting from the VMware world by about 200%. Now, that might just be a claim, you know, people make claims about their software and everything else, but we had to prove it. So let's go into how we ended up having to prove that. We developed the MOS environment and built out specific versions of firmware on some of the things like the AMD chips that they wanted to use, that we were going to use bare metal and not, virtualize anything. That we had to integrate security stuff. The IAM had to be from, a SAML compliant OIDC, and they were intent on using Okta, and then laid out the node counts and all of those things to fit the volume that they were going to do customer setups using this in an automated fashion. So that was just the general initial configuration in the planning phase. We had to resolve some things within our world and within their world to accomplish this. The first things we had to do was make sure that we were all FIPS compliant, because they had all these security and compliance constraints against their world. And in order to do that, we actually had to get patches from AMD that were specific versions of prior patch levels to go to the Ubuntu operating system so that it would be FIPS compliant. And those happen to be the .118 and .119 versions. It couldn't be .120 or .117. It had to be .118 or .119. And they literally backported things for the Ubuntu operating kernel to be specifically for FIPS. And then the hypervisor, of course, had to align with that in the roadmap. So KVM, etc., was kind of an important deal. And we committed to having that accomplished and actually succeeded in doing it, because we were moving from a prior version that had been pipeline oriented for deployment and all of those things to a more containerized control plane world in Mirantis OpenStack for Kubernetes. We had to port forward those things that we had taken care of in the prior version. So the Okta that we had that was working in the prior version, we had to make sure that it was going to work in the new version of Mirantis OpenStack that we were generating. Post aggregates, they wanted to be able to catalog post aggregation in a way that would make sense to where they would do placement, because of the fact they had automated these things. And we had to port some of the things that we had done customized in the prior version of MOS. DVR was in our roadmap. We just accelerated that, and we placed Octavia as a load balancer in the first generation of MOS so that we could align with what they were looking for. And this relates to the speed of performance, we had to work on a hyper-converged infrastructure. We had always placed our storage separately, like Ceph on its own cluster and Nova on its own cluster of systems. But we were now wanting to hyper-converge that. And of course, because they had network performance needs from Mellanox and things like that, we did a move toward the DPDK world, which we'd gotten from places like Ericsson that we had worked with previously, and we incorporated those things into the new first GA of the MOS. You remember we talked about performance and the 200% improvement and everything. Well, we actually had to prove that. So we had to decide whether we were going to use SAP, which probably doesn't work so well, or LVM, which was the logical volume management, or the Nova boot driver to be able to get the kinds of speed that they wanted. And they wanted to use NVMe and SSDs for all of these purposes. So we literally went through the testing of all of those different permutations of our MOSC deployment to find out which one actually performed the absolute best. And we constructed these things completely outside of what we were going to deploy for them for their production environment. We did that for them. They then tested on our equipment to decide which one they wanted. And this is how they tested it. So they did performance testings on single nodes, on multiple nodes, random writes, because most of their stuff is write fast, and you may read it again once later, but just write it fast. And so we had to prove out how fast that could be done. And we set parameters on it, obviously, but you get the idea that we did it with single VMs and then larger VMs. And we were using simple tools like FIO to capture the data. And we proved for ourselves the Nova boot driver won by a lot over everybody else. We also wanted to give them a comfort level that we were going to be able to get them from our prior version of OpenStack to the latest and greatest version. So we not only planned the original deployments and all of the changes and everything else that we were going to do in our prior version to meet their needs, but we also planned out with them. This was all done prior to even starting the original deployment of our older version of Mirantis OpenStack. And as you can see, we got into some specific detail about how we were going to take advantage of the things we've learned in the prior deployment to blend them in, to make the LCM capabilities that we had deployed in available for them. The OpenStack control plane migration was literally going to be a transition from one to the other. And then the OpenStack compute was, we were going to build the new out and literally lift and shift what we had done originally in the prior version into a MOSC framework. And lo and behold, we were successful. I hope I've given you some comfort level in the fact that Mirantis has done this before, making these transitions away from VMware and onto the Mirantis OpenStack for Kubernetes platform, that there are ways of making it simpler, more straightforward, and with less risk than some people who might not plan so successfully as we have, and that we really care about you guys out there, the customer, and that we'll really go out of our way to make sure that you're satisfied that where we're going is where you want to take your journey. And if you've done that, and if you've gotten a little bit more comfort level with that, instead of just replacing your MOSC or your VMware world, you may want to help us extend the journey with you into the full open source environment. And if you do, by moving to a full stack, more cloud native world, so that you're not only doing virtualization, but you're doing containerization the way it was intended, we can tell you that you're going to lower your overall costs, that you're going to have a greater variety of things to be able to put into this new world. And that flexibility is going to stimulate innovation in the way you've done things up until now. You'll find better ways to collaborate in your own organization and real participate we will become collaborators with you and help you through any of those transitions or innovative steps you'd like to try. And that this modern way of operating is going to be far more efficient. And that in the long run, you'll be building cloud native apps that you can host anywhere. They're built in a cloud. They'll be geared toward everything open source, and that there are minimal dependencies, if any at all. And that finally, you get all of this other benefit, because there's a whole world of open source development out there going on that are coming up with new and innovative ideas as we go forward. And I'm inviting all of you to join us in that journey. And when you do, you end up leaving behind your vSphere web console and replacing it with a Kubernetes capable engine that we call Mirantis Kubernetes engine. And on top of that is sitting Mirantis OpenStack for Kubernetes. And within Mirantis OpenStack for Kubernetes, your developers in their own little projects, in their own little user within your OpenStack Kubernetes environment are running Kubernetes, and they are developing against the Kubernetes containerized world. So you've got Kubernetes sitting on OpenStack virtualization, sitting on Kubernetes. And that, we think, is probably the best world to be doing development and continuing your environment forward for a successful development effort and operation of your organization going forward, and getting off of the things that constrain you now in the VMware world. Just before we wrap it up, everybody, I hope you have a great summer. It looks like the sun is out and the sky is beautiful where I am. I hope you have a lovely rest of your day, your week, and your career in computing. Thank you very much.